Hi, we're going to be looking at exam 2. And so here, and so this is exam 2, exam 2, uh, and we'll be looking at page 2 here to kind of help you guys out a little bit. This is a linear equation. How you solve linear equations. I think it's good to have the stories on how to do it. And I'm just kind of looking at my notes here, chapter 2 notes. On page 2, it tells me how to solve the linear ones. And I put the textbook here in the way. And so I figured out how to put them so that you can see them. So this is my whoop, 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 getting it in the picture. And I had, oh, I see. Okay. A little bit too much. Okay. So on this particular problem, there isn't any distributing to do. So I'm solving by a linear equation, no distributing to do. There are no like terms to combine because those are not like terms. I would use add and subtract to get the variables on one side and the numbers on the other. So this is a variable, that's a number, that's a number. So I'm going to take away 1, so the two numbers are together. I get 3x equals 18. And then I'm going to do so now they're separated. And I want to use multiplication and division to isolate the variable. Put your finger on the variable and you divide by 3 to get the variable all by itself. So I'm getting x is 6. Important thing to do is to check your answer to make sure. So when I plug in 3, parenthesis, plus 1 equals 19, I'm going to plug in 6 right there. And I'm going to check it with my calculator. So I got the calculator going here. And 3 times 6 plus 1 ought to be 19, and it is. So 19 equals 19, and that tells us that 6 is a good answer. 6 is a good answer. Too many cups here going. I was helping, and I got a lot of stuff in the way. That's what I got going on. Where you can find some similar problems that you can work them on are, for example, a similar problem could be found on quiz 4, number 1, and lab 10, number 1 and 3. Actually, those are a little bit more challenging than this one, but good ones to go look at anyway. And then in your textbook, and some of you don't have a textbook like this, you have to go on XYZ. But in your textbook, 2.1, number 1, it would be a really good one to look at. And the good news is, so this is from the textbook, 2.1, number 1 would be a really good one to look at. If you could do it, you could definitely do this one. It has the answers in it. I wanted to also just quickly show you here on XYZ. So I'm going to computer screen. Don't get dizzy here. And I'm going on XYZ. So this is 2.1. If I go to the end of this section, I've already had pulled up XYZ and went to chapter 2.1. And here is going. There is the homework right there. So here's number 1. And you can see that, hey, that is a similar problem to this number 1 there on the that I was showing you as one to look at. And then why this is good is that you can click on after you do the problem, you can click on the solution and then know what the solution to number 1 is. And if you don't get 3, then you know that you have made a mistake. And so anyway, I just wanted to show you that. Okay, I'm going to go back to here. and back to paper view. And then this one right here is another linear equation, number 2. So number 2 is another linear equation. Remember how you solve linear equations. Step number 1 is use the distributive property. This problem does have distributive property in it, so I'm going to be distributing right here the -1. So this is 8x, and then when I distribute, I'm going to get -2x plus 4 equals 21. And so when I combine like terms, that would be step 2 on solving a linear equation, is to combine like terms. I get 6x plus 4 is 21. And then I'm going to get the variables on one side and the numbers on the other. So there's a variable, a number. So I'm going to take away 4 to get the numbers together. And I get 6x equals 21, take away 4, which I should know, but I'm really tired. So I'm going to make sure and not mess it up on my calculator, is 17. And then I'm going to divide by 6. Put your finger on x and divide by what you see. So you get x equals 17 over 6. And of course, I want to check my answer and make sure that I have it right. Definitely. So this is, so here I am checking. So 8 times x minus, and then parentheses, 2 times x minus 4 into parentheses equals 21. And what I'm going to be putting in those parentheses is 17 over 6. So right in there, 17 over 6, 17 over 6. I know that I've showed you this trick in class, but I want to show you this trick right now on the calculator. I'm going to put in 17 divided by 6. That's what 17 over 6 is. You notice it gives me the 17 over 6. And that's now saved in the answer. So now it's a little bit easier to put in, because 8, and then instead of typing in 17 over 6, I can just put answer. And then remember what that answer was. It was 17 over 6 because I just put it in there. And then minus 2. Ooh, I wanted parentheses before the 2, so I'm going to back up, put parentheses before the 2. I'm going to put parentheses and put the answer in there. And for 17 over 6, remember, and minus 4. And then in those parentheses and hit equals, and it better be 21. If it's not 21, then I know that there's a boo-boo. And so anyway, that's using the answer key. And so that means 17 over 6 is a good answer. So ones that would be good for you to look at, because they would have distributive property in it for sure. So quiz 4, number 2. I'm not saying that these are the, I'm just trying to pick one off the quiz, one off the lab, or more than one off the lab. So I want a little distributive property. Actually, lab 10, number 1 would be a good one to practice with that. And also number 3, because there's distributive property in that one as well. And then from the textbook, 2.1, just looking for one with a little distributive property that was a homework problem, number 3. And of course, then you have the answer. There are other ones that are good. I'm not saying that this is the only one that is good. Just looking a little bit further, I see 25 is also good. That was a homework problem. Okay, now I'm looking at this one, number 3, and this will be the end of page 2. I know that it's got x squared in it, and the strategy for solving things with x squared in it. So this is back on page 2 on your notes. Page 2 on your notes, get 0 on one side, factor, set the pieces equal to 0, and solve. That's not the only way of solving a quadratic equation. That's just one of the ways. I can't use the square root property because of the middle term. And so I do want to use factoring if I can. I already have 0 on one side. I'm thinking, well, this one is one of my favorite ones to factor. X times x to make 16, 8 times 2, 4 times 4, 1 times 16. All these are possibilities. I want the set that adds up to 10. So -2 and -8. So this is x minus 2 X minus 8 equals 0. X minus, set the pieces equal to 0. X minus 2 equals 0. X minus 8 equals 0. Now these are just linears for us to solve. Add 2. X is 2. Add 8. X is 8. So those are our two solutions. X is 2, comma, X is 8 are our two solutions. And so I've got it where my camera, I've changed where my camera is a little bit, and it's going to fall if I'm not careful. I'm going to have to put my weight back up there on there. I have these dumbbells, and I took my camera down because I was helping my godson with his math. And when I was using my camera on Zoom, it was upside down. And I don't know why. So I'm kind of looking for one that would be possible to solve using a bit of factoring and is also quadratic. I'm looking on the lab, the quiz first. And so just trying to pick out one more problem that you can go look at. Quiz 4, number 3 is similar to that. And lab, so I'm looking through the lab, looking for one that is quadratic. Was hoping for one that you could factor, but here's are some that on lab 11 that can't be factored, which are, but they're all quadratic. And number 2 can be factored even. And so specifically number 2 would be good, and number 3. And then from the textbook, 2.1, like number 9 would be one that would be good. Number 5 would be good. I'm going to put 5 as eraser. There is no eraser there, so it's not really good to say that it's an eraser when it's not. So 5 and 9. Okay, so just some places to look and to get some other problems. So this is page 3. So on this page 3, this problem I got here, it's quadratic. And I noticed that, well, 2 will go into all of the pieces. So I was thinking, hot diggity dog, I can factor that. And so I have 0 on one side. I have the middle term, so I can't use the square root method. So I can pull out a 2. I get x squared minus 9x minus 13 equals 0. 2 doesn't equal 0. So that's not going to give me any solution. And I was going to think about factoring this first, and then I forgot that I was going to do that. I was going to show you that it doesn't factor, I guess. Possibilities here are x times x and 1 times 13 are the only things that multiply together to give 13, but when you subtract them, you don't get 9. So it does not factor. And so I'm going to erase that I tried to factor it, because that's not what I'm going to use. And so when I set the pieces equal to 0, 2 does not equal 0. So that's not going to give me a solution. Then I get x squared minus 9x minus 13 equals 0. And I can't use the square root method to solve that. And I already showed that it can't be factored. So yeah, I'm going to use the quadratic formula. So A is 1, B is negative 9, C is negative 13. So we get x equals negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. So negative 9 in here in the b places, a in here in the a spots, and negative 13 in there. And then I have what I call 3 zones. So negative of negative 9 is one zone, which is 9, plus or minus. And then the second zone is underneath the square root. So I'm getting my calculator. and I'm putting parentheses, -9 squared, minus 4 times 1 times -13. You notice I just put that in just like I saw it there. And then I'm going to hit equals. And so that's 133 underneath that square root. And then my second zone, my third zone, this is zone 2 underneath the square root, right? Zone 3 is the 2 there. And then I would try to reduce the square root of 133. So the square root of 133, which it doesn't reduce. So that's nice. And so this is my answer. I can't do anything more since that didn't reduce. So x equals 9 plus or minus the square root of 133 over 2. And yeah, I can check it. And I'm going to use my answer key on my calculator to check it. So I'm going to put a fraction in. There's two answers here. There's the answer 9 plus the square root of 133, all divided by 2. I'm going to hit equals so that it puts it in so now it's brought it down here. And so it's now the answer is what it is. And then when I put this in, so I'm going to check right here. Check. So this is going to be 2 times squared minus 18 times minus 26, going back to the original, should equal 0 is what it should. And I'm going to put the answer right in here. So I have 2, and then the parentheses, and then the answer squared. And I want to make sure that I go downstairs here, minus 18 times the answer, minus 26. If I don't get 0, then I know I have a mistake. But I did, right? I got 0. Now I want to check the other answer to make sure they're both right. So I'm going to put that in I'm going to put it in as the answer. It's a lot easier to type in one time than to have to type it in twice. I'm kind of lazy. So 9 minus the square root of 133 divided by 2 down here equals. Great. And so now we're going to go 2 times the answer squared minus 18 times the answer minus 26. If that doesn't give you 0, then there's some mistake, but it does. And so I did check it. It worked. I'm like hot diggity dog. And so I'm not sure if you would have to use the quadratic formula. Let me see what I got here. I want to pick one off the quiz. That is maybe not the same as what we've already got going. So from quiz 4, good problems to pick, to work on. I'm not going to be able to help myself. I'm going to put 5 on there, even though it does factor. And I'm going to put 6 on there. I'm not going to be able to help myself, even though you would use a different method on it. But I'm going to put 8 on here, because that one you'll have to use the quadratic formula on. And so, but the others that you didn't have to use the quadratic formula, just trying to name one. If I can name one, I'll be happy. And so, yeah, lab 11, perfect example 3. And then also from the textbook, and now I'm going to have to go over to 2.2, because this problem was a quadratic formula, but any quadratic, whether it's quadratic formula or not, could be replaced right back in this spot. And so textbook homework, I have the notes, so I know what the notes are. I didn't figure out what would be good problems. I should have picked problems out of the notes too. That'd been good. I want 1 and 3. Let me see. 19. No. 16. 19. Gosh, it's so cold in my house. 33. 37. 41. I think 41 would be good. The others I could factor, and I'm not sure if I can factor 41 or not on that. I know the quadratic formula was in 2.2. I'm tired, so I don't know if that one factors or not. It might, but you can definitely solve it by the quadratic formula. Okay, so this one right here, because it's cubic, and so to solve a cubic, you have to get 0 on one side and factor it. And so I noticed that it's a binomial, and I noticed that 125 is 5 to the third. You do you on how you factor that. And so I sing a song, x minus 5, finger over threes, write what you see, square, multiply them together, 5x, square, 5 squared is 25. Signs are same as what you have, opposite of that, always positive, equals 0. Set the pieces equal to 0 after you factor it. So that's x minus 5 equals 0. And so I can solve that by adding 5. So that gives me x is 5. Then the other answer, x squared minus plus 5x plus 25 equals 0. It has the middle term, so I know I can't use the square root method for solving it. And it doesn't factor. I know that because it's the trinomial on the cube. So I'm going to have to use the quadratic formula on this. So this is A is 1, B is 5, C is 25. And the quadratic formula, negative B plus or minus the square root of, I hope I pushed record. I did. B squared minus 4 AC, all divided by 2A. So B is 5, B is 5, A is 1, and 25. And I resolve the three regions, right? So when I resolve this region, I get negative 5. When I resolve underneath the square root, I get, put it in your calculator, right? So clear from what I had in there last time. So that's 5 squared minus 4 times 1. Yeah, you wouldn't have to put in 1. You're right. 25 equals negative 75. So over 2. And then I don't care if you do this by hand or if you do it by your calculator. Your calculator will tell you, this calculator here is the Casio 300. It doesn't do complex numbers. So it will do the square root of 75. The square root of 75 is 5 square roots of 3. And so the square root of negative 75 is 5 square roots of 3i. So here, we're going to get x equals negative 5, and then this is plus or minus 5 square roots of 3i all over 2. 5 and 2 don't reduce with one another, so there's no reason to write it separate from one another. And so sometimes they do reduce. This one did not. So x equals 5, comma, x equals, this is two answers, negative 5 plus or minus 5 square roots of 3i, all divided by 2. And this calculator won't, it'll check the 5, but it won't easily check the one with I. And so my other calculator, this one, will check the one with I. And I wouldn't spend a bunch of time checking that by hand. It'd probably take half an hour to check it by hand, honestly. And so um, uh, it wouldn't be a happy situation to check it by hand. But I could put this calculator in menu. It's already in complex mode. I could put this in here, fraction, -5. I'm going to see if it'll do it actually. Plus 5 square roots of 3. And then outside I, and you just push the, how did that pop up? Why did that pop up? Oh, someone's touching the mouse. Is that me touching the mouse? Okay. The I it was on engineering. I couldn't remember where the I was, and it's on the E and G. And then all divided by 2. Hit um hit enter. It puts it in a different mode. Actually, that's the form that our book puts it in as well. And so now I want to check it. So I'm checking this hard one here. So check, and I just put that in, and this should be the answer, right? Because I hit equals and I got it down here, and I want to check x to the third minus 125, and that ought to equal 0. So I need to do the answer to the third, and then minus 125 equals 0. And so, yeah, it works. Now you can clearly see that if you put in 5, that will also work, right? Because 5 to the third is 125, and 125 minus 125 is 0. So anyway, I didn't check the negative of this, but I'm going to go with that if the other two worked, that that I'm infallible and didn't make any boo-boo on it. You never know. Though if you made a boo-boo or not, unless you check it, but I guess that those come in pairs. Okay, so I'm looking for one that you could practice, uh, that would be a little bit similar. And so this is from quiz 4, number 12. And then from lab 10, number 2 is a cube. It's a little bit different problem, but it's a cube, and this is a cube. You have to factor it. And I was pretty certain I had one that was just like it on a lab, but right now I'm not finding it. And I'm going to see if I can find one out of the textbook in a reasonable amount of time without looking too long or too hard. I know there was an example. I'll find it when I'm not looking, because I know there'll be one in the textbook. 2.3. So this is out of your textbook. It's actually the same problem. So it was a homework problem. 2.3, number 9. Okay. So, and that it turned out to be the same problem. They probably have one, but it's on number 10, and so you wouldn't be able to know the answer to it. But try this problem again. Okay, page 4. So this has got raised to the 4th. And so if you have raised to the 4th, you need to 0 on one side. So this is x to the fourth minus 6x to the second, and I'm going to take away 27. Take away 27 equals 0. And then I told you that if I gave you an x to the fourth one, you would be able to factor it. And so how this factors is x to the second times x to the second. And then I want to multiply together to give 27, but when I subtract them, I get 6. So 9 times 3, the 9 has to be negative and the 3 has to be positive. So this is x squared minus 9 times x squared plus 3 equals 0. Then you could factor x squared minus 9 some more, but you cannot factor x squared plus 3. And so I'm going to go ahead and factor this as a difference of squares. So this is x plus 3, x minus 3 times x squared plus 3 equals 0. Then we got to set the pieces equal to 0. So I have x plus 3 equals 0. Good news, that's easy for me to solve. It's linear. Take away 3, take away 3. I get x equals negative 3. And then the next one, x minus 3 equals 0. Add 3 to both sides. X equals 3. Then that one was linear too. X squared plus 3 equals 0. This one is not linear, it's quadratic. To solve quadratic equations, if they have a missing middle term, you can use the square root method. Otherwise, you can use the quadratic formula or factoring. This one won't factor. I already said it wouldn't factor earlier, so I'm on, well, since it has a missing middle term, I'll do the square root method. So this is x squared. You need to get x squared on one side, so you need to take away 3 from both sides, so equals negative 3. And then the property that you're using is that, is this situation, I'm going to write it right up here. If x squared equals k, then x equals plus or minus the square root of k, and then you reduce or simplify. Rk, right, because I have x squared equals k, Rk is negative 3. So when I do the then, it's going to be x equals plus or minus the square root. Remember what Rk was? So the plus or minus right there, and Rk was negative 3. And then you can use your calculator here to make sure that square root of 3 won't simplify. Square root of 3 won't simplify. I know it's negative 3. This calculator won't do negative 3. This calculator will, but a lot of you don't have a calculator that do negative 3, but I hope that you know that it's I. So x equals plus or minus the square root of 3i. So we have one answer, x equals negative 3. We have another answer, 3. And we have two answers, plus or minus the square root of 3i. So those are 4 answers altogether. That's what we would expect for something that's x to the fourth, 4 answers. So we got 4 answers. Hot diggity dog. To find ones that are sort of similar to that, I'm going to be looking here and see if I see some that are similar to that. This is, and you can check this, but this is quiz 4, number 8. Let's see if I can find one on the lab that's 4th degree. And on a lab, anyway. So cold in my house. I don't know why I've gotten so shivery. This is number 1, lab 12, number 1. And then out of your textbook, I'll be able to find one pretty easily as well. Out of the textbook that you could practice. There's more than this. I'm not trying to name all of them. I'm just trying to give you a few that you could practice. Number 7. And so then this one right here, it's got fractions. So I want to clear the fractions. So you would try to factor the denominators, which these denominators don't factor. And then you build the lowest common denominator by the pieces. So this says it's got to have an x. This says it's got to have a 3. You could put the 3 after the x, but that's not how we typically write it. We typically write the 3 first and the x second. And then I want to multiply all of the pieces by, so this is 1 over x, and I like to put a box around it, a little bit of a boxy gal. 2, I like to put a box around it, equals 2/3. I like to put a box around it. And then I'm going to be coming in here and I'm going to be multiplying by 3x, all of these places. When I have a fraction, I'm going to write it as 3x over 1. That pen didn't work that good. And then when I don't have a fraction, I'm going to say times 3x. And then here I have a fraction, so I'm going to say 3x over 1. And I'm here to reduce. So the x reduces with the x and leaves 3. 2 times 3x is 6x. The 3's cancel with one another, and I get 2x. And it was a fraction, and now it's linear. It's just got x to the first in it. So I want to get, there's no distributive property. There are no like terms to combine, so I'd like to get the variables on one side and the numbers on the other. So I'm going to take away 6x so that the two variables can get together and be on one side. So I get 3 equals negative 4x, and I'm going to divide by negative 4. Last step, divide by negative 4. So my answer is x equals negative 3/4. And you can certainly check that answer, plug it in and check it. And so I checked it on the others with my calculator. I'm not going to take the time to do this because it's already after midnight and I'm 36 minutes into doing this and I'm a little bit pooped. So I'm going to say that I assigned you to check it. And now I am looking for a problem on a quiz that is similar that you could do. There are more problems. There are more problems than this that are similar, but quiz 4. I'm just giving you a few to try. Number 11 turns out a little bit differently, but you can give it a try. 13 turns out very similar. And also, if you're in the mood, 14 would be one that has a fraction in it. Turns out a little harder than this one did. The one that's the closest to this one is 13. On lab 12, one that's pretty similar to this is number 2. I'm trying to just find one. And so I found one. And there's quite a few in your book, but 2.3, number 15. So this is out of the textbook that you could give a try to. 2.3. Also 11 would be lovely as well. So I'll say 11 and 15. And so those are things that you have the answers to. Another one, which would be good, is 27D. Down there, 27D, because you'd have the answers to it. I'm not sure that I assigned 27D, but and in fact, I stopped looking to see which ones I've assigned in the textbook, just because of tiredness and time. This one's absolute value. So I notice the absolute value. I notice the equal. And so I'm saying to myself, in order to solve absolute value, you have to have the absolute value first, all by itself on one side. So I have to add 2 to both sides to get the absolute value by itself. That's a 1. Absolute value equals 6. Then you should pause and look at what you have. So when you have your absolute value, and there's 3 things it could possibly be. It could be 0. It could be positive. It could be negative. And what you do next depends on which one of those 3 that it is. Ours is positive. So since it's positive, you break it into 2 cases. That's negative 2x plus 1 equals negative 6, the opposite. The other answer will be negative 2x plus 1 equals positive 6. And then you solve those 2 cases. If it had been 0, I would have had only one case, and if it would have been negative, I would have said there was no solution and been done with the problem. So I'm going to take away 1 from both sides. So actually 0 and negative would have been easier if it had then, and divide by -2. So I get x equals negative divided by a negative is a positive 7/2. So that's one of my answers. So taking away 1 gives 5. -2x equals 5. Dividing by -2 gives x equals -5/2. So those are my 2 answers. Sorry, I got it where you couldn't see. It happens to me because I'm silly sometimes. And so I wanted to find some that have absolute value in them from a quiz, and it's equals. And so I'm getting on quiz 5 and looking for ones that have absolute value in them for you to look at and solve. And so quiz 5, good ones to practice would be 6A and 6B. Also good would be 7 and 8 would be good. And what the heck, I'll throw in 9 while we're there. And then lab, on a lab, I'm only looking for 1, but there was actually so many of them that were right there together that I couldn't help myself, and I named them all. Oh, that's quiz 4. I'm not going to look at quiz 4 probably anymore. I'm not sure. Oh, am I going to sneeze? I think I am going to. Excuse me. Sorry for sneezing right in the video. Lab 15, number 2 would be a good one to look at. And then if you wanted to look at one out of your textbook, then 2.6 are the absolute value ones. And I'm just going to name one out of the textbook. I'm going to choose number 7. So textbook, but there's a lot of them there. 2.6, number 7, if you wanted to practice. Another one, page 5. It's got a square root in it. If you're solving a problem with a square root in it, it's got to have the square root all by itself on one side. So if I take away 9 from both sides, I get the square root equals, so that's 3x minus 2, equals -2. Then you pause and look at what you got. And you could have, the choices are positive, a negative, or a variable. In this case, I have a negative. And since I have a negative, there's no solution. Some problems that have square roots in them that you could look at and give a try to. Was there one on, I said I wasn't going to look at quiz 4 anymore, but for some reason I thought there was one with a square root on quiz 4, and there is. So on quiz 4, number 7 has a variable on the other side. And what else we got here? Man, my sneezing was crazy. And let's see if I can find one with a square root on it on a lab. So this is lab 12, number 3, and it has got a positive number on the other side. And I know we had one with a negative number in notes. That's absolute value. That's not square root. And I was going to look and see if I could find one in the textbook because I can't help myself. But look in there. Those are absolute value. The square root ones were in, what section were the square root ones in? Were they in, they weren't in 2.2, they were in 2.3, maybe. Yep, there they are. I want one with a negative on the other side for the excitement of the negative on the other side. Of course, they're all even. With a negative on the other side. I knew that we did, oh, no, 53. No, that's cube root though. Mm, I wanted to do one that had a negative on the other side. That was from our book. I know I did one in notes. It's so fun because you just get to say no solution. Oh, there's one. There it is. Couldn't find it, but now I can. It's textbook 2.365 to if you wanted to give a practice to it, number C, particularly number C. Actually has all of the types there on number 65. So that you could compare them all. Okay, solve the following compound inequalities. Um, write the solution set in interval notation. Okay, so this one is just linear inequality. So I just have to add 1 to both sides. So I get 3x is greater than 6. Then I divide by 3. Now 3 is positive, so I don't have to flip the symbol. I just leave the symbol the same. So since 3 was positive, 3 had been negative, no flip. Everyone loves to flip. That's actually the mistake people usually make is they flip when they shouldn't. So this is x is greater than 2. It asks us to write our answer in interval notation, and I would prefer to graph it first and then write it in interval notation. So 2 is right here. It's open, and it says x is greater than. So the things that are greater than are that direction. So now if I write this in interval notation, it starts at 2 and parentheses for 2 and goes to infinity. Then the next one is got 3 sides. And so truly compound inequality. Oh, you wanted me to find one of those out of my book? Well, you know I'll be able to do it. And off of the lab as well. Okay, those are quadratic. That's linear. Oh, yeah, this would be a good one. This is quiz 5. Number 4 would be good. And so that you could go ahead and look at. It's a little harder. Quiz 5, number 4 problem there is a little harder than the problem I have here. You know how that goes sometimes. And when you're just looking quickly. Lab 14, number 1, and it's a little harder than the one I have here too. But I can get one that is closer to this one from your book. Definitely. 2.5, number 7. So this is from the text book. 2.5, number 7 is a good one to look at. And what the heck? While we're here, we'll do another one. How about number 11? That one has a fraction in it, so it's actually a little harder than this one as well. And how about number 15? Why not? That one has some distributive property in it. Okay, so not trying to name a bunch, but just a couple that you can go and look. It's not a very good 7, but this is not a very good eraser. Okay, so what you want to do is you want to leave the variable in the middle. So I would add 0.4 to all 3 sides. So when the dust clears, here I get 0.9. And over here, I get 1.5. Then I'm going to divide by 0.3. Put your finger on A, divide by what you see. So dividing by 0.3. And this is where I would recommend people use their calculator. 0.9 divided by 0.3 is equal to 3. This is equal to A. And 1.5 divided by 3 is equal to 5. Okay, no flip of the symbols because 0.3 was positive. So I have to flip the symbols. So I would prefer to graph it first and then write it in interval notation 3 to 5. Close circles. So our solutions are between 3 and 5. Close circle. So it goes, these are closed circles, and the glare of my thing is making them look open, but they're closed. And so I've tried to solid them in, and so you can see, and so 3 to 5. And brackets because it was closed circle. So if I wanted to find a similar problem on a quiz, quiz 5, number 5 is really similar. On a lab, telling you these problems so that you could go and practice them if you wanted. I think that might be the same problem here on the lab as on the quiz. If it's not, it's really, they're really, really close to one another. Number 2. And out of the textbook, 2.5. 23 is a good one to practice. 25 is a good one to practice. It's almost the same problem. And so, are there other good ones to practice? Did I say it was just good enough to name one? Yeah, it is. I don't want to look too hard because I'm tired. Okay, so we did a lovely job on that, page 6. So I noticed that it is absolute value and it's inequality. So how I solve absolute value inequality, there is more than one way of doing it, but how I do it, you can do it any way you want. I do the boundary method, and boundary happens at equals. Good news, I know how to solve equals. We learned how to solve those in earlier. When you have equals with absolute value, you have to get the absolute value all by itself. So you add 5 to both sides. So here I get the absolute value of x plus 4 equals 13. 8 plus 5 is 13. Then you pause and you look at what you have here, and the possibilities are 0, a negative, or a positive. And this is a positive. And depending on what you have of those 3, then you would do, you would, if it was 0, you would have one solution and you would go find it. If it's negative, there would be no boundary points. There would be one boundary point if it was 0. But if it's positive, there's 2 boundary points. How you find them is x plus 4 equals negative 13, and x plus 4 equals 13. So when I take away 4, I get a boundary point of negative 17. And when I take away 4, I get a boundary point of 9, I believe. Then what you're supposed to do with the boundary points is you put them on the number line. So step 1 was to find the boundary. Step 2 is to put them on the number line. These would both be, because this is greater than or equal to, this tells us they're closed. So when I put it on the number line, here's negative 17, it's closed. Here's 9, it's closed. Then what I want to do, step 3, is I want to do a test point. Step 3, do a test point. Pick an easy point. I'm going to pick 0. This was x's, so x is 0. It's going to be my test point. You put it back in the original, and you see if it's true. So the absolute value of 0 plus 4 minus 5 is greater than 8. So this is 0 plus 4 is 4, and the absolute value of 4 is 4. Minus 5 is greater than or equal to 8. Negative 1 is greater than or equal to 8. That is false. So where 0 is, negative 17 to 9, 0's in between, is false. So our solutions, the true regions, are after, because it alternates on absolute value, for sure alternates, are before negative 17 and after 9. In interval notation, it said interval notation. I'm going to have, you need parentheses for infinity. So negative infinity to negative 17, bracket, union, 9 to infinity. This one was an outie. Some of them are innies. How you know if it's an outie or an innie? Outie, outside, or innie, inside, is whether when you do a test point. Okay, so we did a lovely job on that. I will find a couple for you to practice. So on the quiz idea. Oh, I found another one of oh no, don't go putting other stuff on others, because I found another one of those cubes that I was looking for and couldn't find. You know how that goes. And so some to practice here. This is quiz 5. Good ones to practice would be 10A and 10B and 11 and 12 and 13 are all good to practice. From a lab, I'm just looking for one on a lab. I don't have very many problems on labs, but just 3 each day. It's hard to. Oh, there's another square root one that I didn't name. Darn it. When I was naming square root ones, you know how that goes. That's the. Okay, lab 15, number 3. And then from the textbook, these are in the last section. They're in 2.6, absolute values. And of course, you can, so there's a lot of them that you could look at. So this is in 2.6. And I don't know. Which one should I name? There's so many to choose from. I wanted one where you had to add to both sides, like we had to do. And so I'm going to choose 43. Okay. Then this next one is quadratic inequality. How you solve quadratic inequality. Number 1 is you find the boundary. The boundary happens at equals. X squared minus 16 equals 0. So this is quadratic, and I have 3 techniques for solving quadratics. If it has a missing middle term, you can use the square root method. If you can factor it, you can get 0 on one side and factor it. If it can't factor and it doesn't have a missing middle term, then you can use the quadratic formula, and actually you can use the quadratic formula for all of them. This particular one factors really easily. It's a difference of squares. X plus 4, x minus 4 equals 0. So when I set the pieces equal to 0 and I solve, I get boundary points of negative 4. And when I add 4, positive 4. So the second step is to put them on the number line. And this says they're open. Open, open, open. So here on my number line is -4, open. And here's 4 on my number line, open. Then the third step is to test a point. It will alternate if you don't have repeated root. So I don't have repeated root. -4 wasn't the answer twice. So it'll should alternate. So I'm just going to test x is 0. It's my favorite point to choose. X is 0. And I'm going to put that in the original. So this is x squared minus 16 is less than 0. I'm putting in 0. And when I square it, I get 0. When I take away 16, I get minus 16 is less than 0. That's true. So 0 is in between these two. That's true. And the other regions should alternate if you don't have repeated roots. So this should be false over here. And this should be false over here. I'm only interested in the true region, and the true region is from -4 to 4. So in interval notation, that's -4 to 4. And to find some that are similar to look at, you're going to have to go on quiz 5. And quiz 5, number 2, would be similar to that. Is there going to be another one? Another quadratic inequality when you only have 15 problems on quiz 2? Nope, not going to be another one. I'll find one on a lab though. I'm pretty certain there is one on a lab as well. Try to have one of every type, every place. Doesn't always work out, but try to. This is lab 14, number 3. And then from the textbook, there'll be tons of them. And the answers in the textbook too, so that you can look. So those are in 2.5. Yeah, they are in 2.5. And textbook 2.5, like number 31. Went in the hole. I wrote right in the hole there. Okay. So this one here, next one, number 14, is it's called rational inequality, is what it is. And where you start off with is where it's undefined. Undefined is where the denominator is equal to 0. I'm going to put DEN for denominator because I'm tired. And so that's where x plus 5 times x minus 7 is equal to 0. Good news, at 0 on one side, and someone already factored it for me. Thank you, whoever factored that for me. So x plus 5 equals 0, or x minus 7 equals 0. So we take away 5, we get x is -5, and we get add 7, we get x is 7. Those are undefined points, is what they are, and they always go on your number line as open. Number line, open. Always open on the undefined points. So when I put these on the number line, which I'm going to do here in a minute, they're open. Then I'm going to find the boundary points. The boundary happens at equals. So this is x minus 2 over this hideous fraction, x plus 5, x minus 7 equals 0. So remember, when you have a fraction like that, rational, you multiply by the lowest common denominator. How you find the lowest common denominator is you factor the denominator. Thank you, whoever factored this for me. So nice of you. And you build it. So the lowest common denominator, it has an x plus 5 and an x minus 7. And I'm going to multiply this by it, and I'm going to multiply the 0 by it. Now, the reason I'm going to be lazy here and not show that is because when you multiply this by it, do you agree that those two things would cancel out and give us x minus 2? I know we've seen this. And when you multiply 0 by this, well, 0 just wipes it out and you get 0. So it turns out pretty easy to solve. It would have been harder if there had been 1 on the other side of the equation, and I know that there was one that we did either on a quiz or a lab or in notes that had 1 on the other side. So this is x is 2, so I'm going to add 2 to solve it. And this goes with whatever you have. And so this goes with open or closed based on that right there. So this is closed. So we have for our number line 2 points that are open and 1 point that is closed. And you put them in numerical order. So -5 goes on there and it's open. 2 goes on there and it's closed. And 7 goes on there and it's open. And friends, it really doesn't matter scale. And so if you're looking at that and you're saying you don't have good scale, you're right. I'm not really drawing my number line right here for scale. I'm drawing it to figure out where my solutions are. This is close, close, close. And I know that the glare, there were no repeated points here, so it should alternate. And so I'm going to test just 1 point. I do recommend testing all of the points. I remember saying to Lucas, do you test all the points or what do you do? And he said, yeah, I just test all the points so that I make sure that I don't mess up. I'm just tired. And so otherwise I would test something in every single region, but instead I'm telling you the little theorem of when it's going to alternate. And that's when you don't have repeated root. So here, when we put in 0, we get -2 in the numerator. When we put in 0, we get +5 down here, and we get 0 minus 7 down there. And I want to know, is that smaller than 0? And you can certainly put that in your calculator. It's -2 over -35, smaller than 0. 2 over 35, smaller than 0. And that's a positive number, and positive numbers are not smaller than 0, so that's false. Now, where was x is 0? Well, x is 0 fell between -5 and 2, and we just found out that that region was false. I'm going to use an F for false, so that means the region next door to it would be true, and next door to it would be true. It should alternate if you don't have repeated root and false. So now I have where the true regions are. So the true regions down here and in between here. So the true region goes from -infinity to -5, open circle, union, and then 2 to 7, and brackets on the 2 because it was closed circle on the 2, and then open on the 7. So parenthesis on the 7, getting the glare off of it. Finding some problems that are similar to it. So on quiz 5, number 3. And on a lab, so cold. I don't know why I'm so cold. Makes me wonder about myself. Lab 15, number 1. This one's quiz 5, number 3 is really similar problem. And of course, out of your book, and a lot of the ones out of the book are harder. This is number 1. Can hardly see that one. I got some glare problems. I don't usually have glare. What have I got going? I think I have set up my light different after I took it apart for helping William. Okay, 2.5 from the textbook. So 2.5, and then ones that are similar. Well, 41 is at least in the neighborhood of the same difficulty as far as not being too, but like 43 is harder and 45 is definitely harder. 44 is perfect. And in fact, 44 is the one that we did in notes there, but of course you don't have the answers. I'm going to go ahead and put 43, even though I admit that 43 is harder than this problem here. And so, okay, we did a lovely job I did a lovely job at choosing some there. And so page 7. And most people probably already stopped watching the video because most people did really good on page 7. On a zip line created by Mr. Myers in his backyard by his children, riders drop 8 feet while covering a distance of 15 feet along the ground. How long is the zip line? Draw a picture, set up an equation, and solve it. Show all your work. So here's my zip line. So a zip line goes from like a tree. They might have hung it in a tree. This is some picture of a kid with a zip line in a tree. So maybe this is in a tree, right? Attached to a tree. So there's our tree. And we know that this is, what did they say, 8 feet? This was our zip line. And this is along the ground. How many feet along the ground? 15 feet. So this is a right triangle. And across from the right angle, that is usually called C. So I'm going to call it C. And so using the Pythagorean theorem, a squared plus b squared equals c squared. So I have 8 squared. This pencil's about to go in the trash. It has no eraser. Equals c squared. And now the lead keeps breaking. And do you think it could be me? No, not me. Couldn't be me. So I just put in my calculator 8 squared plus 15 squared, and it's 289 equals c squared. And then this is quadratic, and it doesn't have a middle term, so I could use the square root method. How the square root method goes, it goes like this. If you have x squared equals k, then x equals plus or minus the square root of k. In my case, it was called c, but my k value is 289. So c equals plus or minus the square root of 289. Then I want to see if 289 simplifies on my calculator. 289. And it does, it's 17. So c equals plus or minus 17. Now, this is the length of the zip line in Mr. Myers's backyard, and lengths have to be positive, so c equals 17. But this is how you would solve it had you got something that didn't have to be positive. So this is 17 feet. Then looking for some problems that are similar on a quiz. That's a word problem, but it's not similar on quiz 4, number 15. But quiz 5, number 1 is exactly the same problem except for different numbers. And are there any other word problems there? No. Okay, lab 10. Excuse me, labs, not lab 10. Then there were there were a lot of word problems that just to practice word problems, right? Because this is just a word problem. On lab 13, 1, 2, and 3. Where 3 is a Pythagorean theorem 1. This is a Pythagorean theorem 1. So that's lovely. It named every single problem on all of the labs, even though, okay. Oh, lab 16 also has a bunch of Pythagorean theorem ones because I really wanted to make sure that you practiced your Pythagorean theorem ones. 1, 2, and 3 is not a Pythagorean theorem, but it is a word problem. So these are Pythagorean theorem ones. Are there any in the book? And the answer is, I'm pretty sure there probably are. And I'm pretty sure they're probably on 2. Oh, I'm wrong. They're on 2.4, huh? The word problems in the book were harder, I have to admit. And so, but there is ones that are right triangle ones, and you can find them in the textbook. on 2.4, number 5. Number 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 6 is way harder. And so anyway, but that's okay. That's all we need is one. Okay. And so I hope that you practice some out of the book, some out the other quizzes and labs so that you can really, really nail it is what I'm hoping that you do. Okay, stop video.